A wing on an airplane creates lift, and there are many factors that affect lift, and one of those factors is called angle of attack. Well, you might ask, well, what's angle of attack? Well, the angle of attack is the difference between the angle of the wing and the angle of the wind hitting that wing. Right now, they're lined up, and that's called zero angle of attack. As a plane climbs, the wing starts to increase like this, and the difference between the wind and the wing is, in this case, maybe around 20 or 30 degrees angle of attack. And as the angle of attack increases, we find that something will happen with lift. And we can do an experiment to find out what happens. We can take a ruler and to measure our lift, and I can take a protractor to measure the angle of attack. I take a hairdryer to represent the wind, and then some cardstock here to represent our wing. And by having the wind blow at 0 degree angle of attack, I see that my wing creates a certain amount of lift. Now, if I increase that angle of attack, let's say to 10 degrees, I find that that wing creates a lot more lift. And if I go to 30 degrees angle of attack, I see that my wing doesn't lift at all. And you might say, well, what's up? Well, if we take the data and we graph it, we see that a typical curve looks like this. As angle of attack increases, lift increases up to a certain point. And that certain point is called the critical angle of attack. Because when my wing has a greater angle of attack than this point right here, my lift starts to get less, to the point that eventually my wing will create no lift. And you know, that's very important for pilots to know, because that's called a stall angle. And that's our connection to aviation.